Welcome to our final video of the series. Oh, don't be so sad. You won't need me anymore at the end of this video. You will have graduated to a statistics semi-expert. But before you can officially graduate, you need to learn about two more tests, the t-test and the ANOVA test. Both tests can be used when you have different groups of participants and you want to compare their means on a quantitative variable. You remember quantitative variables, don't you? That's right, quantitative variables are the ones measured with either ratio or interval scales. Oh, and also, in order to make sense of the statistics for the ANOVA or the t-test, you need to look at the p-value. That's right, your good old friend, the p-value. A t-test is used to compare two different groups of participants. For example, you might be interested in comparing two sections of a course, or you might be interested in comparing males to females on a given variable. So if we stick with our idea of comparing males to females, let's imagine we want to compare whether males scored higher on the midterm assessment compared to females. In this case, I would run a t-test because the variable grades on the midterm is measured with a ratio scale where scores can vary between 0 and 100. Just like we did when we wanted to find the p-value of a correlation test, to have access to that statistics, I need to use the data analysis function. And more specifically, the t-test to sample assuming equal variances. However, before we can run our analyses, we need to reorganize our data. Basically, we need to create two columns based on our groups and their scores on our variable. I have already done so here. So in column 1, you can see the averages on the midterm female students got, and the scores obtained by males can be found in column 2. Next, I can choose the right test. When asked for the range of variable 1, I will select all the scores obtained by female students, and I will do the same for males on their variable 2 range. And then before I click OK, I just need to make sure that my alpha is set to 0.05. Similar to the correlation table we got in a different video, the output gives us a lot of different information, some of which is not useful at this point. The important information is highlighted in yellow in the table. First, we need to understand what a t-test does. It compares the mean of two different groups. So basically, the first row shows the mean score for grades obtained by our 8 females and the mean score of our 7 males on the same variable. The rest of the information highlighted will be used to report our findings. So to write the result of a t-test, you need to use this format. The letter here shows us the test we ran, while the number in brackets is the degrees of freedom that we find on row number 9. The number after the equal sign is the value of our statistics found on row 10. And the last part is our p-value. We typically don't report the exact p-value, but we just state whether it's above or below our threshold of 0.05. So remember, a t-test allows you to say whether two groups have different mean scores on a quantitative variable. So let's try to keep it as simple as possible here. Basically, an ANOVA test is similar to a t-test, but it looks at 3 or more groups. To determine if my test is significant and if there's a significant differences between my group, I will have to look at my p-value, just like we did for previous tests. So let's look at an example here. Imagine we want to compare the results of 3 sections of Humanities 101 to make sure that the way the course is taught is coherent across instructors. Here, each column represents the score on a test for a different group of students. To obtain the necessary information for my ANOVA tests, I need to, once again, use the data analysis function, but this time I will choose ANOVA single factor. Once this is done, I can choose all my data when it comes to input range. The result will appear on a different tab, and just like I did for the t-test, I highlighted the important information for us in yellow. In the column Average, you will find the mean score for each section of Humanities 101. And I can also easily see that I had 11 students per group. While I'm glad to know what the averages are, what I really want to know is my p-value, as I kind of suspect a significant difference between 67.91% and 79.36%. So when I look at my p-value, well, I realize that it is below 0.05. So I have indeed found a significant difference, just like I suspected. Basically, students from Section 3 scored significantly better than students in Section 2. Just like for the t-test, the rest of the information highlighted will be used to report our findings. The format of the ANOVA test is very similar to the t-test and should be as follows. The main difference here compared to our t-test is that we have two sets of degrees of freedom, one found on row 12 and the other one found on row 13. Also, because I found something statistically significant, I would also write the following sentences in the results section right after reporting the numbers. Yes, I think a long breath is needed here. But you almost made it through. So to summarize things simply, t-tests are used to compare means for two groups, while ANOVA tests are used to compare means for 3 or more groups. That's the most important thing I want you to remember here. The rest, you can rewatch this video for as many times as you want. Isn't this wonderful? Keep in mind that this video was meant to give you a head start with your statistical analyses. It was not meant to be exhaustive by any means, so it is possible that you need to research further some statistical analyses or even talk to your supervisor. But you know what? I'm confident that you can do this. Now, all you have to do is trust yourself. So, thanks for sticking with me until the end, and I wish you the best of luck with the rest of your project.